Okay, good day everyone. Welcome to Marinai's Powerhouse Team Review and Training Center. Welcome to our electrical engineering video book. No, this is actually studying electrical engineering subjects. No, from electrical principles to electrical circuits to machineries up to power systems. So my name is Engineer Reggie Marinay. So in the Philippines, no, you can call me Kuya Reds. No, the word Kuya meaning I'm your big brother, no, your older brother, and your Reg is my shorter name. Okay, that's my nickname. Okay, so next partner. So before we go to our topic, so we encourage everyone to please subscribe, no, my YouTube channel, the Reggie Marina YouTube channel. So please subscribe, comment, and share our YouTube channel. So the Marinai's Powerhouse Team Review and Training Center. So we offer electrical engineering, master electrician, master plumber review, and licensure exam for teachers. So we are conducting online review program via Zoom. Okay, let's go now to our topic. Okay, let's go to our topic. Our topic for today is about the Millman's Theorem. No? It permits any number of parallel branches consisting of voltage sources and impedances to be reduced to a single equivalent voltage source and equivalent impedance. And the voltage is expressed as, so let us call our voltage V. So this is our voltage V, which is the common voltage, no, that is equal to the summation of the short circuit currents all over the summation of the conductances. Okay? For us to understand this, okay, let's go to our first problem. Okay, by the way, so before I solve this first problem, I will get some questions from this book. This is a very popular book from our country, of course. I give respect to this book. I give a lot of respect. I even encourage students to our reviewee to have this book. It's a must for you to have this book, no? So actually, I don't have a formal agreement with the author of the book. I just found out that in the bookstore that this is a very useful book for this student. So I want to every Filipino students to have this book. Okay, so I'll be getting some problems from this book. Okay. And then these some problems, now maybe we can have it a shorter way of discussing these problems. Okay, so using the Millman's theorem. No? Okay, let's go now with problem number 1. Okay, let's go on to problem number 1. So we have a 12 volts battery of 0.05 ohm resistance and another battery of 12 volts and 0.075 ohm resistance supply power to a 2 ohm resistor. What is the current through the load? So, what is the current through the load? No, nandiyan agad yung sagot, partner. Sana wala muna. Okay, anyway. So, I have to draw this circuit. Okay. So, let me see the circuit. Where is the circuit? Okay, so I will draw the circuit. So we have a purely parallel circuit here. Okay. So we have, how much is that? 0.05. Okay. Then we have a single resistor at the middle. Then we have another resistor in series with this 12 volts source. Okay, we have a 12 volt source, 0.075. That is the ohms. Then at the middle, we have the 2 ohms. Then we have 0.05. 0.05. Then we have the 12 volts. So take note, guys, that we have, this is a plus, this is minus, plus and minus. Okay? what is the current through the load? The load is actually this, the current flowing here. This is the load current. What is the load current here? Okay. I will complete all the branch currents. I will call this as our I sub 1. And this is our I sub 2. And let's say our load current is our I sub 3. Okay? That is our I sub 3. Now, let us have our Millman's voltage. Where is our Millman's voltage? This is our Millman's voltage. We have a voltmeter here that will measure the voltage at the two common nodes. Please take note that our this is our circuit. So we have here our voltmeter that is actually the voltage here, no? The voltage here and the voltage in here and the voltage here, which is the common voltage for the three branch circuits. So we have three branches, no? For this circuit, we have 1, 2, and 3 branches for this purely parallel circuit. Now, let us get our voltage V. What is our voltage V? So that is equal to the summation of short circuit current is simply the ratio of the voltage to the resistance of a particular branch, no? But why is it called as a short circuit current, no? It is assumed to be that there is a short circuiting conductor here. Let's say we have a short circuiting conductor here. Okay? So, let's say if we put a short circuiting conductor here, our current I sub 1 will just be, let's say we have a current here, this current will just flow here, wherein that will just be 12 by Ohm's law, that is the voltage over the resistance. So 12 over the resistance, 0.05. Okay? For the second branch, since there is no voltage here, so just put here 0 volt, and then we have 2 ohms. That is the voltage over resistance. Then what about here, our third branch? So assuming that there is a short circuiting conductor, or just simply take a look at the voltage source, we have here 12 volts divided by the resistance, which is 0.075 ohms. And what about now the conductance? Take note that the conductance is the reciprocal of the resistance. So take a look here. So this is 1 over 0.05 plus 1 over, we have 2 here, then plus 1 over, we have 0.075. Okay? So let us calculate our voltage V here. Okay. Our voltage V, okay, let's calculate this one. We have 12 over 0.05. Okay. This will just become 0. And then plus 12 over 0.075. Then all over, we have 1 over 0.05. Okay. Then plus 1 over 2. Then plus 1 over 0.075. So our answer would be 11.82 volts. So let us put here 11.82 volts here. Okay? So we have 11.82 volts. That will be our Millman's voltage here. So let us solve now for the branch currents, no? Okay. For branch currents. Okay. So we have the branch currents. I will erase this short circuiting conductor. Okay. For branch currents, we have to consider one loop, one complete loop. So this is our one complete loop. Take a look here. Let us consider this one complete loop. So I will assume that this is the positive and negative of the voltmeter. Okay. This current I sub 1, let it flow here. Okay. So I will redraw the circuit. Let's say for I sub 1. For I1, so we have here, I will draw the circuit here. Okay. Then we have here. Then our voltmeter here. Okay. This is plus, this is minus. Okay. So this is our I sub 1. Then we have here 0.05 ohm. Then we have here the 12 volts. Okay. I will make use of by PLM. What is PLM? Okay, in our review center, this is what we call the powerhouse let it flow method. What do you mean by powerhouse let it flow method? By PLM. PLM. So let I1 flows. Let I1 flows. Okay? Following its direction. So this is our I sub 1 here. Okay? There you are. So, I will put here I sub 1. That is equal to, okay, this current I sub 1, it leaves. Okay? It leaves on the positive terminal of the battery. So, doon siya lumabas, ha, mga ka-wear pa. So, therefore, it is 12. Put here 12. What about for voltmeter? Again, it leaves on the negative terminal. Doon siya lumabas, no? It leaves on the negative terminal of B. Divided by the resistance. Because current is voltage over resistance. What is the resistance here? The resistance is 0.05. So therefore, we just have to substitute our 11.82 here. Okay. This is 11.82 volts. Okay. So what will be the value? Okay, we have 12, then minus. Okay, take note here that I sub 1, it leaves on the negative terminal of the battery. Then our I sub 1, it leaves on the positive terminal. That's why this is positive 12. And this is negative B. Because I sub 1 leaves on the negative terminal of the battery. Okay? And then, of course, the resistance path, no? The resistance where our I sub 1 flows. Okay. So, again, so we have here 12 minus 11.82. 11.82 equals, then divided by 0.05. Equals, our answer is 3.6 amperes. Is this correct? Let's double check. So we have 12 minus 11.82 divided by 0.05. 3.6. That's correct. 3.6 amperes. Then what about now for our I sub 2? Our I sub 2. Okay, for our I sub 2, take a look here for our I sub 2. No need to draw this kind of circuit. It's very obvious here that let us apply the powerhouse let it flow method. Let us consider one complete loop. One complete loop is this loop. Okay. There you are. Okay. So, our I sub 2, guys, it will be what now? Okay. As you see here, it leaves on the positive terminal of 12 volts. That's why it is 12. It leaves on the negative terminal of the voltmeter. So that is minus V. Resistance path is 0.075. Okay, what will be our answer here? 12 minus 11.82 equals, and then divided by 0.075 equals. So our answer is 2.4. 2.4. 2.4 amperes. There you are. Okay? What about now for our I sub 2? I sub 3, I mean. I sub 3. Take a look here, guys. For our I sub 3, no need to draw. So our I sub 3 is here. We are going to consider this one complete loop. Always include the voltmeter. No, lagi natin isasama yung voltmeter, ha, mga kawerpa. So we have here, this current IL or I sub 3, it lives on the positive terminal of the voltmeter. That is why, let us put here, positive V. And then, divided by 2. So, divided by 2, there you are. So, the answer would be, what is, that is 11.82, and then divided by 2. So, our answer here, guys, is 5.91. 5.91 amperes. So, that will be our answer. Let's take a look at our choices. What letter is this, guys? What letter is this? Okay, there you are. Okay, the answer would be letter D. Okay, 5.91. That will be our load current also. Okay, there you are. Okay, that is also our load current. 5.91. No? So, as you see here, no? Let's take a look at the solution from the book. Okay, this is the solution from the book. Okay, so he uses the Kirchhoff's voltage law. There's no problem using the KVL. So, it's just that we have another solution. It's up for you to choose, no? So that you have, or better, use the two method to solve. Okay? Okay. That's correct. 5.91, no? The same as found in the book. Okay. There's a way of checking if our answer I1, I2, and I3 are correct, no? How to check this? How to check the 3? How to check? Or just check. Okay? Is that the way to do it? No, of course not. Okay. So, we have to consider the Kirchhoff current law at this node. Let's say this is node A. At node A, okay, let's say to check. Okay, to check. Okay, let us consider by Kirchhoff current law at node A. Okay, take a look here, guys. Kirchhoff current law at node A. The current I sub 1, okay, plus I sub 2, take a look here. The current entering is equal to the current leaving. So, therefore, I sub 1, that is entering, plus I sub 2, also entering, that is equal to the current leaving, which is our I sub 3. As shown here, so we have here 3.6 plus 2.4, is equal approximately to 5.91. Okay, so let us check this. We have 3.6 plus 2.4. Okay, although that is 6, that is almost equal to 5.91. So it's just that we have some rounding off of values, so that's correct. Okay, guys. So if we are going to make the V here, no, you replace the 11.82 into its fractional form. I can assure, or we can assure that this will have an equal value or almost equal value. I mean, the difference will be a lesser. Okay? So, let's go now to our number 2 problem. Next problem. For number 2. Okay, find the value of the voltage V. Okay, I will not draw anymore the circuit. It's very clear there, our circuit. So we have our, okay, and then in series with the 1 ohm resistor. Okay, then we have the 12 volts battery in series with 0.1 ohm, a single resistor on the third branch. Then we have a lamp that is 60 watts and 12 volts lamp. Okay, although we already have the answer there. Okay, next slide please. Next slide please. Okay, let's take a look at the solution from the book. Okay, there will be no problem. So, solving for the resistance of the lamp, of course, RL is VL squared over PL. Now, that's already given. 12 volts squared and over 60. So, the answer here is 2.4. No? That is for the lamp. No? As you see here, the rightmost circuit. Rightmost part of the circuit. Okay, so from the book, he uses the Nodal Method. Okay, I'll be using the Millman's theorem to solve our Millman's voltage or voltage V. So take a look here, guys. Again. So we have how many branches again? We have 1, 2, 3, 4 branches. We have 4 branches. Okay. So our circuit here, we have 24 over 1. 24 over 1. And then we have plus, the second branch is 12 over, what's that? 12 over 0.1. 12 over 0.1. Okay? Then plus, okay, that is 0 over 4. 0 over 4. Okay? And then plus, so, for the lamp, we have a resistor. There's no voltage. Make it 0. Then over 2.4 ohms. 2.4 ohms. Okay? For the conductances, so we have 1 over 1. Okay? Plus 1 over 0.1. Plus 1 over 4. Plus 1 over 2.4. Okay? So, let us have this. So, we have 24 plus 12 over 0.1. Okay, so we only have a 0 there, 2 zeros. Okay, then all over. So we have 1 plus 1 over 0.1 plus 1 over 4. Okay, then plus 1 over 2.4. Okay, so equals. So our answer here is 12.342857114. May I see? What will be our answer here? So that is 12.34. So ito sagot natin, mga kawerpa. So 12.34 volts. Let's see. Okay. Parehas ba sagot natin kay Engineer Rojas? No? Let's see if that is the same. Let's see. Okay, that's correct. No? That's very easy. Okay, that's very easy. Okay, so for Nodal Method, I think it's a longer way. No? So you see, we are to count the I1 is equal to I2 plus I3 plus I4. That's the first line of the solution. Okay, the next is the second, third, fourth. On the fifth line, before there are 4 lines before the final answer. We only have 1 line, no? Isang linya lang bago lalabas kaagad yung sagot natin na 12.34. Okay, so this is easier, no? Using the Millman's theorem for this particular problem. Okay, next problem, please. Okay, let's go now with problem number 3. Okay, number 3. A resistor R is connected across two batteries, A and B, in parallel. The open circuit EMF and internal resistance of the batteries are 12 volts and 2 ohms, 8 volts and 1 ohm respectively. Determine the ohmic value of R if the power absorbed by R is 7.656 watts. Okay, it's obvious that the answer is 10 ohms. Let's see for the solution of Engineer Rojas. Let's see. Okay, so we have a 10 ohms. That's the answer. He uses there the Nodal Method. But don't you know, Millman's theorem is easier, a lot easier compared to this Nodal Method. So I'll show this to you guys. Okay, I'll go directly with the Millman's voltage. Okay, Millman's voltage. Let's say that will be our V sub L. So our V sub L here, so that is equal to what now? Okay, so let us read the problem again. I read again the problem. The problem, question. Okay, so I will, I think it's better that I will redraw the circuit. Okay, so I will redraw the circuit. So there will be two batteries here. Then we have resistor here. Okay, so the two batteries, we have 12 and 2 ohms. 12 volts, 2 ohms battery. We have 8 volts and 1 ohm. 8 volts and 1 ohm. 8 and 1. Okay? Okay, determine the ohmic value of R. So this is our question, our R. That is the question. If the power absorbed by R is, so let's say this is our R. So the power at the load, it will be how much? 7 point, that is 7.656 watts. Okay, that is our PL. That is our PL. Okay, then what is power given the resistance? Okay, then we are given also the voltage. Take a look here that we have a load voltage here. Okay, and that will be our Millman's voltage also. That is the common voltage. Okay, so the power simply equal to V squared over R, isn't it? V squared over R. Okay, V squared over R. So how to get our voltage V? Our voltage V now will be equal to what? V will be equal to okay, PL, and then we have to take the square root, right? There you are. So that will be square root of P times R. So that will be our load voltage. That will be our load voltage here. Okay? P is already given here. Now, using the Millman's theorem, okay, now, by Millman's theorem, let us have, okay, again, our formula is the voltage is equal to circuit current over the summation of the conductances. That is our formula. Now, what is our V? That is our VL here. So that is equal to the square root of P, which is what? 7.656656. Okay? Then multiplied by simply R. That is the unknown. So that is equal to, okay, take a look here. That is 12 over 2. That is 12 over 2. 12 over 2. So this will be 0 over R. Okay? Because there is no series voltage here. 0 over R. That is simply 0. What about here, guys? That will be 8 over 1. Okay? So that will be plus 8 over 1. What about the resistances? For the first branch, so we have here 1/2. For the second branch, remember, for the second branch here, so that is the unknown. So make it 1 over R. Then plus, this is 1 over 1. 1 over 1. As you see here, this is R, this is also R. There is only one unknown. Okay? We can make use of our calculator. Okay? So, gamitan natin ng powerhouse calculator techniques. Okay? We have the square root of 7.656. Then we have R. Make it as variable X in our calculator. Okay? Twelve over 2 is 6 plus 8. So, 6 plus 8 is 14. So, we have, this is 0.5, this is 1, so that will be 1.5. 1.5, okay? So that it will be easier. 1 over R, let us replace that by variable X. Okay, in our calculator, so make it shift calc equals. Okay, our answer here is 10.00037,319. So, therefore, our R simply equal to 10 ohms. See? So, this is a lot easier. Okay? Using the Millman's theorem. No? Wherein, from the book, how many steps before it goes to the final answer? Okay? From the Nodal Method, from the equation IA plus IB is equal to 1. That's one line. Let us count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that 11, 12, 13? Okay, around 13 or 14 lines. So we just 1 or 2 lines. Actually, only one line because I just show here the formula, right? As you see here, there is only one line. Imagine that the 13 steps, I only replace this. Not I, no? Millman's. No? Sorry to say, no? Not I, no? It's not me. Millman's. Millman's made the theorem to simplify. You see, there is only one line. Okay? Of course, we just have to show this. Okay? Even if you count this, 1 against 14 lines, right? So this will save a lot of your time, especially in the licensure exam where it is a time pressure exam, no? In the board examination or the state board, no? Whatever you call it. Now, here in my country, in the Philippines, we call this as board exam. Okay? So that's it. So our answer would be letter. Partner, anong letter natin? Okay, letter A is our answer. Okay? So, there it goes. Okay? So, next slide, partner. Okay, that's it for this part 1 of our Millman's Theorem. So, I'll see you on the next video. Thank you.